Let us look at proposition number 19 of book 8 of Euclid's Elements. The proposition says between two similar solid numbers, there fall two mean proportional numbers, and the solid number has to the solid number the ratio triplicate of that which the corresponding sides have to the corresponding sides. So let's see what it means and how it can be proved. A and B are two similar solid numbers. Solid numbers are basically product of three numbers. Previously we saw similar plane numbers. Plane numbers are product of two numbers. So C, D, E be the sides of A, F, G, H be the sides of B. And similarity means what here? Similar solid numbers. It means C is to D is equal to F is to G. And D is to E is equal to G is to H. Let K is equal to C times D. L is equal to F times G. So K is C times D and L is F times G. And C is to D will be equal to F is to G. Yes, because the sides are proportional. So that means K and L are similar plane numbers. The mean proportional M between K and L. How do we get M between K and L? Because we know there is going to be a mean proportional between K and L. So see here, we have C is to D is equal to F is to G. That means M will be equal to D times F, and C is to F is equal to K is to M. Again, we can figure out C measures K and F measures M same number of times. So which means K, M and L are in the continuous proportion in the ratio of C is to F. We had C is to D is equal to F is to G. Alternately, we can write it as C is to F is equal to D is to G. Similarly, DE is to GH. Alternately, we can write it as D is to G is equal to E is to H. And KML are in continuous proportion in the ratio of C is to F, D is to G, E is to H, because these are all equal to each other. So since KML is continuous proportion in the ratio of C is to F, that means it is also in the ratio of D is to G and E is to H. Let N be equal to E times M, E times M, and let O is equal to H times M. A is equal to what? A is equal to C times D times E, but C times D is equal to what? Is K. So we can say A is equal to K times E, and B is equal to F times G times H, which can be written as, since F times G is L, we can write it as L times H. So now we can say A is to M is equal to A is to N. How? Because K measures A E times and M measures N E times. So K is to M equal to A is to. So which means C is to F equal to D is to G equal to E is to H is equal to A is to N. C is to F is equal to D is to G is equal to E is to H, and K is to M is equal to A is to N. So we can write that as well. Actually, we could have added K is to M also. Now, E is to H is equal to N is to O. E is to H is equal to N is to O. How? Because E measures N M times. and H measures O. H measures O m times. So both are m times. So we can write it as E is to H equal to N is to O. So which means we can continue this proportion. C is to F equal to D is to G is equal to E is to H is equal to A is to N equal to N is to O. Now, M is to L is equal to O is to B. How? Because M measures O H times and L measures B H times. So M is to L equal to O is to. So which means we can continue this proportion further. C is to F equal to D is to G equal to E is to H is equal to A is to N is equal to N is to O is equal to O is to. So that means A, N, O, B are in continuous proportion of the sides of solid numbers. A has to B has a triplicate ratio of A is to N. A is to B is equal to A cube is to N cube. This is one of our previous propositions which we have already proved. But A is to N equal to C is to F equal to D is to G is equal to E is to H. So which means A is to B has a triplicate ratio of C is to F or D is to G or E is to H. So that means A is to B has a triplicate ratio of the corresponding sides CF, DG and EH. That is proposition number 19 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share. That's it for now.